Hello students, welcome to a new lecture of solid state physics, and in today's lecture we will learn something more about the crystal structure, the basics of the crystal structure. Before going to the crystal structure, we would like to ponder over the two simple questions that why do we study the crystalline solids? Because in this course the main focus is on the crystalline solids. I have explained the concept of crystalline solids in my earlier lectures. You can watch the videos and of course if you have some query you can ask. So what is so special about the crystalline structures or the crystalline solids? Is it only that they have a very good shape and they look good and they have a very shine on them like gemstones? It is not so. The crystalline solids are of special interest because of the semiconductor devices. These semiconductors, they are generally found in the crystalline solid form, and the electrical properties are strongly dependent on the structure. Semiconductor solids are crystalline in nature, like silicon, germanium we are considering, they are crystalline solids, and there is a strong dependence of the structure on the electronic properties. Moreover, I have discussed in my previous lecture that their crystals are anisotropic in nature, and this anisotropy leads to the development or manifestation of further important properties like ferroelectric property, ferromagnetic property, piezoelectric. This is not very closely related to some crystalline structure, but we will discuss in our later studies about the magnetic properties. The most important is the piezoelectric. These are the properties that are found in the crystalline solids, and they are attributed to the anisotropy of the crystal. So these properties have very vast application in the field of research in technology and in scientific science to find new physics. Piezoelectric, dielectric, most important. So these properties are exclusively found due to anisotropy, which is a prominent feature of the crystal structure. That is why we are interested in studying the crystal structure. So let us now start our journey towards studying the crystal structure. It is not a single lecture, or it is not a single piece of information that will provide you with everything you require for solid state physics. It is a journey, and we are starting our journey. Although we have started, now we are going to take some important steps in our journey. So whenever we are concerned with crystal structure, before going to the crystal structure, what we have to do is to understand the relation between the things we are seeing with naked eyes and the things that are inside the crystal. We cannot see. We have to relate the observed properties with the internal structure of the crystal. So before starting this lecture on structural study, I am showing you here some diagrams, some photographs that are observable with the naked eye. They are some famous buildings. This one is famous, of course. This is not at all famous. This one is, let me designate them figure A and B. B is not at all famous. It is found in, you can see it in the rural areas. This is a famous building, a historical structure. Now what is common in these two structures is the repetition. This repetition is common. You can see that if this is a part of this building, This part is repeating. I could not paste the entire photograph here, but throughout the building, it is about 2 kilometers long. The same thing is repeating along the horizontal direction, along the vertical direction, above and below. Here also you can see a repetition of these blocks throughout the walls. So what we are starting with our lecture, our journey towards understanding the solid state structure, is with the concept of repetition. This repetition takes the form of periodicity. This repetition takes the form of regularity. This repetition is the famous symmetry in crystals that involves the entire crystallographic study and many mathematical tools. So this is the key word in solid state physics, this repetition, and it appears in many forms, in periodicity, regularity and symmetry and everything. So what is this periodicity, repetition all about? So whenever we are discussing a crystal system, crystal and crystal systems are all about repetitions. Now what is repeated, how is repeated? Whenever we have a crystal, it means that we have a molecule or atom or anything that is making up the material is a copy of an object that is chosen arbitrarily. It is a copy of a object that has been chosen, and that particular object is repeating itself in a definite manner along the different directions. And the most common word that you will come across while studying this solid state structure or crystallography is motif. Not motive, it is motif. Motif means it is a kind of decorative image or design that forms a pattern. The most prominent or the most common example is the mosaic structure, mosaic, that is found in our homes. Now it is the age of marble tiling, but initially there were mosaics. And this mosaic structure is very interesting when we are going to study the polycrystalline solids. So this is repeating throughout the structure. If you have a marble flooring, you can see a particular shape of a marble piece. It is repeating itself throughout the structure, throughout the room. So this is a kind of repetition, but this repetition in case of crystalline solids, it has to be in a particular manner. A periodic pattern or a regular pattern or a particular arrangement appears when we have a systematic repetition of the motif. How is it so? Suppose this square is the motif and this square is repeating 1, 2, 3, 4, 5, 6, 7, 8. Everyone is identical. Now how it is formed? Let me show you with an example. Suppose I copy this figure and I paste it here. This I pasted here. Now again I am pasting this diagram here. Again I am pasting this diagram here, and I can go on pasting this square side by side. So what is happening? What you see that there are 8 identical squares. What I say that this square 1 is repeating itself 8 times along the x-axis. This is the x-axis. Square 1 is repeating itself 8 times. Here it is repeating 8 times, and along the vertical down direction it is also repeating 8 times, and it is forming a pattern. The same thing can be observed in 2 dimensions or in 3 dimensions. Now the next thing that you come across, that is these numbers 217, 230. Sometimes it is very funny that during my teaching of this solid state physics, many students say that these numbers, what are these numbers? They appear like some numbers in astrology, because they were confused a bit, but it is quite usual, it happens. So this 217 and 230, it is the number of ways in which a particular motif can be repeated in 1 dimension, 2 dimension and 3 dimension. You cannot repeat a motif, and this cannot word is very important. This is a kind of restriction that is put, that is due to the symmetry conditions. Whenever you have symmetry, you have some restrictions. You cannot repeat an object in more than 17 types. There are only 17 ways in which a object can be repeated in 2 dimensions. In 3 dimensions there are 230 types, means you can repeat the object in 230 ways. In 1 dimension there are only 2 types. We will see how they are forming. Now what is there? This is about the repetition, and your structure is forming by repetition. Similar to your floor tiling, suppose this is one marble, you place another marble here, you place another marble here, you place another marble here, you place another here, and you are getting a pattern. Many times you will see during the work that at the corners the worker has to cut the tiles to put it in shape. So there is a restriction. So your floor tiling is complete when the entire floor is covered. This entire space covering is also very important. We will see it later. Now how to repeat the things? We are dealing with atoms or molecules or the constituent particles of the system. We are not able to see them, we are not able to hold them in the hand and repeat the things. So these repetitions are described by the mathematical operations. Description of repetition. This repetition process is described by some mathematical operations, and these are of course types of motion you have studied in your preliminary classes. These are the types of types of motion. Now these types, they are going to produce the repetition. How it will produce the repetition, we will see. Here is another example, and here the motif is this square. This is the motif that is repeated 1, 2, 3, 4, 5, 6, 7. 7 times it is repeated. It is not that there are, you can say that there are 7 squares, but each square, this one is 1 square and it is repeated 7 times, and you can see it is a single combined pattern. This is a single combined pattern. It is not separate. So you put it here, you get a structure. You get a structure. This is repetition. Now what are these mathematical operations or geometrical operations that can cause repetition? Now let us try to understand this concept. So before going to this concept, I think I should tell about the left and right-handed objects. Before going to this section, it is necessary. So this is your left hand and this is your right hand, most probably. Left and right hand. Now if you have a pair of gloves you understand, surgical gloves, you cannot wear the left hand gloves in the right hand. Your thumb will create a problem. Your thumb will not fit. That is creating the asymmetry. That is creating the asymmetry. This is the problem. Let me show you with a diagram, with a picture. So there are two forms of the same object. One is right-handed, other is the left-handed, like our right hand and left hand. You cannot wear the right hand gloves on the left hand gloves. Left hand. Similarly, the left hand glove cannot be worn on the right hand. So this is the concept of handedness. This is the concept of handedness. Now, when an object is found in left and right-handed patterns, it is called enantiomorph. It is called enantiomorph. Another example is this 7. This one is 7 left-handed. We are considering this as the reference, this head. It is towards left, so it is left-handed 7. This is right-handed 7. And these pairs are called enantiomorphs. Now, how can you change the right hand to a left hand? By reflection. It is a very common thing, and you have studied this thing in the preliminary optics. It is called lateral inversion. If you stand before the mirror, your right hand will appear as the left and the left will appear as right. So this reflection is causing your left and right hand gloves, they were not fitting. Your right hand gloves was not fitting in the left hand. Your right hand thumb is pointing towards left and your left hand thumb is pointing towards right. You cannot overlap them. But when you are reflecting, your right hand becomes left hand and you can superimpose. So this reflection, this physical phenomena of reflection is causing a kind of symmetry, or what we call the congruence or equivalence. When two objects can be overlapped on each other, they are called congruent. Here you have an example. We have a comma here, and this is right-handed comma, this is left-handed comma. We are considering this point, this axis, this head to show the right-handed and left-handed comma. Now this is the XY axis. This is like your left hand and this is like your right hand. This is your thumb. This is your thumb. Try to imagine, because solid state crystallography is more about imagination. You have to picturize many things in the mind. So these are your two hands. This is X axis. This one is X dash. This change into X dash is occurring by reflection about Y. So this X dash is, if this is the mirror, your X axis is reflected and it is found here. So this is X dash. Now your right-handed comma, left-handed comma becomes this right-handed comma. Similarly, Y axis can be transformed into Y dash by reflection along the X axis. You can try that. So asymmetrical objects that exist in left and right-handed form, they are called enantiomorphs. Like this 7. Same thing will happen with the 7 also. Now the figures, the objects can either be superimposable on each other or they are enantiomorphs. They are said to be equivalent. Both are 7. It is not that this is 7 and this is 9. Another very interesting example is 69. And please don't take this in a different way. Many times we see in movies that 6 is inverted and it is becoming 9. So it is, I am not saying that it is reflection. It is a mathematical operation that is changing this 6 into 9. And this 69 is a very interesting number. So this is an enantiomorphism. There are many objects like that exist in right and left-handed forms. So what we have seen in the above examples that certain movements can lead to this left hand to right hand and then congruence. There are certain movements. Here we have seen reflection in case of thumb, gloves and 7, and there is some kind of rotation for this 69. There will be rotation. You may have seen in movies. He is slamming the door and the 6 is becoming 9 and everything is changing. So this is kind of motion. Now how to represent these motions? We have to represent these motions. We cannot move the particles or the atoms. We have to represent these motions by mathematical operations. The best example is you take a rubber stamp. Many times we have to check before putting the rubber stamp that whether its orientation is right or not. Now suppose you put a comma at this position M, which is 1, and here you are putting this comma. We are printing this comma. Now the object is same. This is comma. If you have to put a comma like stamp, or you are not writing, you are putting a rubber stamp of a comma like in this shape, in this position 2, what you have to do? You have to make some movements, and it is specified that the distance between 1 and 2 will be of t units. You have to stamp or print a comma of this shape at point 2 at a distance t units. What type of motions, what type of movements you will do? This is done by 2 steps. First, you have to make a translation from position 1 to position 2. And then what you have to do, you have to rotate by a given angle alpha. This alpha may be anything. We are concerned about the motion, not the exact specification of the data. So what you are doing, you are taking this comma here and you are rotating by angle alpha, and you are getting a comma at point 2. So these two commas are asymmetrical. So what we are doing? We are doing translation and rotation, and they have to be described mathematically. So they are mathematical operations. Mathematical operations. This is the entire process that has been shown here. This is how we can print a comma at 2. This is for asymmetric objects. Now a special kind of repetition, it can be obtained when you are continuing a certain mathematical operation. Now we will come to this point, that what is the relation between repetition and symmetry. I will not elongate this lecture, I will do it in parts, but this thing is important. So let us first have an introduction of this particular topic. So the concept of symmetry is the most fundamental concept of the entire natural science, and it is the foundation stone of crystallography. And this symmetry is the most general law that is inherently present in crystal structures. Symmetry, and on the basis of this everything is defined, X-ray crystal diffraction and everything. Symmetry is the inherent property of crystal. Inherent property of crystals. Crystal is all about symmetry. So what is symmetry? Let me explain with the help of a diagram. This is a quartz crystal, and I will discuss it in the next section. This is a quartz crystal, and what is seen here, if you do a rotation about this axis 3 by angle theta 120 degree, what we see after rotation is same as before rotation. After rotation by 120 degree along axis 3, crystal is same as it was before rotation. So before and after the situations are same. Which means that if this is before rotation, if this is the situation before rotation, before and after rotation, this is the situation after rotation by 120 degree about this 3 axis 3, what you can do, you can superimpose this diagram on this diagram and they look the same. It looks like a single diagram. But if you are not able to overlap it, if you are doing it like this, if something is happening that I am not able to rotate it here, suppose this is the situation, then it is not overlapping. So this phenomena is one example of symmetry. In detail, we will discuss the concept of symmetry in the next lecture. So by the time, stay tuned, watch and like the videos, share with your friends, and if you have some comments, let me know in the comment section. Thank you.